Hey, let's continue on with our story about the Pythagorean theorem. Today we'll talk about the Pythagorean inequalities. So let's say we knew that a squared plus b squared was not equal to c squared, where a and b and c are side lengths of a triangle, and c is at least as great as either a or b. That is a less than or equal to c, b less than or equal to c. Or if you like, just imagine that we've placed a, b, and c in order and c comes last. Okay, so what do we know if a squared plus b squared is not equal to c squared? Equal to c squared. Well, if the triangle were a right triangle, then by the Pythagorean theorem, c squared would be the hypotenuse. Well, c would be the hypotenuse. That would mean that c squared equals a squared plus b squared. So it's not a right triangle if a squared plus b squared is not equal to c squared. Well, that means, of course, that it's either obtuse or acute, because if you categorize a triangle by angle measure, you have three and only three possibilities: obtuse, acute, and right. So the question is, can we tell, okay, based on the side lengths of a triangle? Well, before we answer that question, let me uh, talk a little bit about angle measures in triangles and how we categorize them. So let us say that a triangle has an obtuse angle. Does it follow that the triangle is obtuse? Well, yes, for sure. That just ultimately is the definition of an obtuse triangle. It is one with at least one obtuse angle. But how about this question? Let's say that a triangle has an acute angle. Does it follow that the triangle is acute? Well, no, of course it does not, because every triangle, as we proved in a previous chapter, every triangle has at least one acute. As a matter of fact, every triangle has at least two acute angles. So from the fact that a triangle has an acute angle, it does not follow that it is acute. Instead, you must not know that all three angles are acute if you are to conclude that a triangle is an acute triangle. So keep that in mind as we drew the proofs that follow. All right, so we have two theorems to prove. I'll call them Pythagorean inequality O and Pythagorean inequality A. I'll let you think about what the O and the A might signify. But for O, what we have is this: a triangle ABC with A, B, and C given in order. That is A less than or equal to C and B less than or equal to C. And also let us say that A squared plus B squared is less than c squared. Okay, so these are the theorems about where a squared plus b squared is not equal to c squared. And let us say in this case that it is less than c squared. Now, what we wish to prove here is that the triangle is obtuse. And the strategy is very much like the strategy employed in the proof of the converse of the Pythagorean theorem, where we constructed a kind of reference or comparison right triangle. So in this case, we construct a right triangle RST with its right angle at T, so that the right angle includes a pair of sides that are equal to the side of length, I'll call it B. Let me take a second to get my pen. The side of length little b in one and the side of length little a in the other. So you can see that this is what has been done in the diagram. And then what we'll do is we'll compare these two triangles together. Okay. So you might wonder what theorem or theorems would be used in the proof of this. Well, think back to the inequality chapter. We had a pair of theorems. I'll just give you a little hint here. We had a pair of theorems, one of which was called hinge, and the other of which was called converse hinge. Okay, and you might go and look on your theorem sheet to see what they say. But I'll remind you, the hinge theorem says this. Let us say that we have two triangles. Okay? Two sides of one equal to two sides of the other, and the included angle in one greater than the included angle in the other. It follows, by hinge, that the triangle with the greater included angle has the greater third side. And converse hinge says that, well, once again, if you've got two triangles with two sides of one equal to two sides of the other, if one has a greater third side than the other, then the one with the greater third side has the greater included angle. Now, I'll tell you that for both of these theorems, you'll use either hinge or converse hinge in the proof. And let's think just a little bit about this one, the Pythagorean inequality O. Which one we would use? Well, what we're going to do ultimately is we're going to compare C in triangle ABC to T in triangle RST, and of course here's where our little r and our little s are, we follow the convention that the lowercase letter is opposite its uppercase counterpart. So ultimately what we'll do is we'll compare little c to little t, and the hope is that we will be able to conclude that little c is greater than little t, and hopefully thereby conclude that angle C must be greater than a right angle, which would of course make it an obtuse angle. So it looks to me like, and I want you to think through this on your own, of course, but it looks to me like we would use the converse of the hinge theorem, where the goal would be, so here's the goal, is to prove that little c is greater than little t. So when you do the proof on the worksheet, that will be your goal, okay? Oh, and a little hint here about how it is that you'll use this. You'll use the Pythagorean theorem along the way, okay? Because triangle RST is a right triangle, which means that we may apply the Pythagorean theorem to it and conclude specifically that r squared plus t squared, excuse me, r squared plus s squared is equal to t squared, okay? Is equal to t squared. So I'll let you think about how the pieces of this puzzle will be put together. And then second, the Pythagorean inequality A, very much like what we had before, except the given now includes the statement that a squared plus b squared is greater than c squared. And we'll prove that triangle ABC is acute. And there'll be a twist in this one, okay? So we will conclude, first of all, after you've done the necessary work, that angle C is an acute angle, but it won't follow from that alone that triangle ABC is acute, because remember, as I reminded you of a moment ago, to conclude that a triangle is acute, we must know that all three of its angles are acute. So we will initially conclude that angle C is acute, but we must then go forward. We must go past that and prove that angles A and B are also acute as well. And key here will be part of our given where we said that A is less than or equal to C and B is less than or equal to C. That, together with the conclusion that C is acute, will allow us to conclude that angles A and B are acute as well. And once we know that all three angles are acute, we will be able to say that it's an acute triangle. And once again, what will be crucial here is either hinge or converse hinge. And like I said before, I do believe it'll be converse hinge. So you'll get to think about the details on the worksheet. Now, finally, what are we able to do with all of this? Well, what we're able to do is this. If you give us the three side lengths of a triangle, we will be able to decisively declare whether it is obtuse, right, or acute. Okay, so let's say that our triangle has side lengths 60, 91, 108. And notice that they're given in order. Okay, if they're not given in order, we have to order them. And then the question is this. Let us take the first, after we've ordered them, square it. Let us take the second, after we've ordered it, square it. Sum those two squares, and then compare that to 108 squared. Now, of course, there are three possibilities for what that might be, for what we would put in the box. We'd either have to put less than, we would have to put greater than, or we would have to put equal to, okay? If we put equal to, of course, and you could do the computation, it's very simple, just multiply these out, maybe use a calculator. If it turns out that equality is what we have, then this, of course, is a right triangle. If, on the other hand, 60 squared plus 91 squared is less than 108 squared, we'll use one of the theorems we just proved, and we conclude that the triangle would be obtuse. If, on the other hand, 108 squared is less than 60 squared plus 91 squared, it would be acute. Okay, so however this turns out, we can know what kind of triangle that it is. And I won't talk through the details of the second one with side lengths 4 and 2 and 3. Just do know that before we apply our test, we must write our lengths in order. And then we use those quantities in that order, right? And we ask, what is the relationship of 2 squared plus 3 squared to 4 squared? That is what goes in the box. Is it less than, greater than, or equal to? And once we know what goes in the box, we can make our decision about what kind of triangle this is.